Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. In this lecture, we are going to learn object-oriented paradigm. So far, we have learned quite a lot about module, coherent coupling, information hiding, data encapsulation, and so on. Now, let's get some conclusion for the knowledge that we have learned before. Coherent and coupling of objects. Okay. The only feature unique to the object-oriented paradigm is inheritance. Okay. In the previous lecture, actually we have given the example of struct in C language. And the struct will never become a class because it cannot support inheritance. So that's why we say that the only feature unique to the object-oriented paradigm is inheritance. Only the object data structure supporting inheritance can be called class. And the instance of the class is called objects. Two instances from the same class have the same coherence. So it does not matter if this functionality is inherited or not. That means this method or function is unique function or is inherited from its superclass, doesn't matter. Okay? It makes no difference. Right? The advantages of objects. We have talked so much about objects, and does an object has any advantages? The answer is yes. It is the same as the advantages of object data types. Information hiding, data abstraction, and procedural abstraction. All of these are advantages of object data types. And the inheritance provides further data abstraction. That means easier and less error-proof product development and easier maintenance. Okay? So that means inheritance makes it easier to develop and to maintain. And what's more, objects are more reusable than modules with functional coherence. Actually, functional coherence is something that the best can be achieved with structural paradigm. Well, informational coherence is something that can be achieved by only object-oriented paradigm. And of course, the classes and objects are more reusable. The structured paradigm has great success initially. We must admit this. The structured paradigm has been quite successful in early 1990s, but it started to fail with larger products. Let's say, if the system has more than 50,000 lines of code, the structured paradigm will fail. And it will cause a lot of maintenance problems. So let's analyze this. Why structural paradigm will fail, okay, when the software system's size becomes larger? Well, actually structured functions are action-oriented or data-oriented, but not both. That means not at the same time. So action-oriented, okay, finite state machines or data flow diagrams, and so on. And data-oriented means anti-relationship diagrams or Jackson's method, and so on. Let's remember, in the first chapter, we have understood that a software system composed of code, data, and documents. And surely the code and data are something related with the system running. So we can see that both the action and the data are very important for the performance of the software system. And both of them should be taken with equal importance. But from previous discussion, we found that structural paradigm takes the importance of data or action, but never at the same time. That's a problem. Okay. But in the object-oriented paradigm, the object That means the software components that incorporates both data and actions that are performed on that data. So this object, or maybe we can call it a class, is the basic unit of the software system. Well, we understand that a class or object composed of both data and actions. Let's say the example, bank account, in a bank system. This class will have data, account balance, and actions such as deposit, withdraw, determine balance. So we can see that following object-oriented paradigm, the designer and the programmers have to consider both the data and action with equal importance. Otherwise, he cannot design or implement the class or object. So that means he cannot ignore either data or action. So these two diagrams compare the structure paradigm and object-oriented paradigm for the example bank account. Let's say in the structured paradigm, account balance surely is the data of the account. And there are some other functions, deposit, withdraw, determine balance. All these three functions operate on the data, account balance. But the data and the functions are not in the same data structure. So that means they are not considered at the same time. Let's take a look at diagram B. This is the object-oriented paradigm. For the object account, this big circle, or maybe you can call it a big pie, is indicate account. And you see in the center, there is the account balance, that's the data. And we get the deposit, withdraw, determine balance. These three methods operate on the same data structure balance. And both the data and the methods are within the same data structure. You can call it abstract data structure, okay, and you can also call it an object. And the other class, okay, if you want to deposit or to determine balance, or to withdraw, the only thing the other class need to do is just send a message to this object. And then this object will fulfill the requirements for the other class. So what do we get so far? First, information hiding. The details of the implementation of the methods is within the object. It's invisible from outside. So we get information hiding. Surely it is very safe, right? We get the highest security. Okay. And what's more, this kind of design or this kind of solution surely lead to responsibility-driven design. Just as we have said, the other class only sends some message to this object if he hope this object to determine balance for him, or deposit, or withdraw. And how to implement this requirement, or how to implement this method, is just the responsibility of class account. So that means the other class doesn't need to worry about the details of implementation for deposit or for withdrawal, and only account, okay, only object or class account will worry about this because it is its own responsibility. So we call it responsibility-driven design. And we find that this paradigm makes things easier, okay, and clearer. You can see from this interface that things are very simple. So surely this will help the designer to get a system with a better architecture of the whole software system. So it will be very good for maintenance and development. Well, the key aspects of object-oriented solution will include both the conceptual independence and the physical independence. Conceptual independence will lead to encapsulation, and the physical independence will lead to information hiding. And the the classes, okay, will have high reusability. And we understand that reusability is very important for software development. Well, responsibility-driven design. Responsibility-driven design is something unique for object-oriented paradigm. It is not unique for software system. Sometimes in our life, we also counter such kind of things. Actually, our society has followed these rules already. Okay. Let's say, suppose your auntie's birthday is coming, and you want to send some flowers to her, and your aunt lives in another city. So, what will you do? Actually, it's quite simple, quite easy. You can just call some hotline, okay, for flowers, and you can tell them what kind of flowers you want and how much, and where the flowers supposed to be delivered to, and who is supposed to receive the flowers. So we can find that all the details of the implementation of flower delivery is hidden from you. You get nothing about that kind of details. And actually you don't care either. So this is also kind of information hiding. Okay. What you have to do is just send a message, okay, your requirement, to the flower company, right, a flower shop, cool, to tell them your requirements. So in our software system, we say in this way, send message to a method of an object. Well, so responsibility-driven design is also called design by contract. When we talk about the paradigm, maybe we can discuss it further from the point of view of software life cycle. From this table, on the left hand is the software life cycle for structured paradigm, and on the right hand is the object-oriented paradigm. Structured paradigm, step 1, requirements phase. Step 2, specification is also called analysis phase. And step 3, design phase. Step 4, implementation phase. Step 5, integration phase. Step 6, maintenance phase. And 7, retirement. Well, let's see, object-oriented paradigm. Phase 1, requirements phase. Phase 2, object-oriented analysis phase. Phase 3, object-oriented design phase. Phase 4, object-oriented programming phase. Phase 5, integration phase. Phase 6, maintenance phase. Phase 7, retirement. Well, we find that from phase 2, objects entered already. So it becomes something like this. From phase 2, we got objects. Well, actually the task for object-oriented analysis design includes determine what the product is to do, extract the objects, detail design, and so on. And surely this will be the good basic for object-oriented programming. Because with OOA and OOD, surely the target system should be implemented in some appropriate object-oriented programming languages. So just now we have discussed the advantages of objects, okay, for software system. And from the point of view of software life cycle, that means from the point of view of software engineering, we find that the object enter the system, enter the software life cycle quite early. Okay? So that means try to bring the advantages of object-oriented paradigm to the software engineering, okay, as early as possible. Okay? So that means to take advantages of object-oriented paradigm as more as possible. So this is the advantages of object-oriented software engineering. And so far, you must understand that the software engineering that you are learn is object-oriented software engineering. So far, object-oriented software engineering is the most advanced software engineering, okay, theory and technique. Well, Okay, so much for this point.